Welcome all of you. In this video, we are going to learn about the three-phase fully controlled converters. Three-phase fully controlled converters, when we are going to look at about that one, first basic about three-phase fully controlled converters, or it is called rectifier. It will be convert AC into the DC. So here input is a three-phase AC power supply. So here you can look at three-phase AC power supply. We are going to apply, and then what is this one means? This is called a three-phase VI measurement. So we have the direct one of the measurement block like about the voltmeter, ammeter, as similar to that one. This is the three-phase VI measurements. When we are going to using for this type of the measurement, it will be integrated for a phase to phase. For example, one voltmeter connected R to Y, another voltmeter connected to Y to B, another voltmeter is connected R to B. Like about it will be three voltmeter is will going to connected and then brought into the waveform. So it is integrated. So like we have direct meter is available, measurement meter, that is the meter is called VI measurements. Okay, through that one we're going to use the measurement meters, and here we're going to see about the directly input of that three phase. And the next one is you can see the power circuit. The power circuit, it has that a three leg, and each leg about the two switches are connected. Okay, this is the positive group of the switches. The numbers is 1 3 5, like we have learned about the theoretically. Another one is let we going to see in the practical session. So here about the negative group are the even numbers. So it is start from the 4 6 2. So why it is a number is there 1 2 3 4 5 6 means based on the sequence wise we are giving the numbers. What is the sequence means 6 1 1 2 2 3 3 4 4 5 5 6, like it will be operated. Then next one is the RLC series branch. We are going to help with the help of that one. We will going to connect it about the load. So first initially we are going to go with that R load method. R load method we are going to try on that one. R load method. We're going to resistance about 10 ohm we are going to apply. And then especially input source frequency we will going to set 50 hertz as per our Indian government standard frequency. 50 hertz will going to give, otherwise the waveform it will not get clearly. So this is about that one power circuit. So input is we will go to 50 hertz, and amplitude whatever you can give the amplitude. So here phase 2 phase voltage you can give for 440 voltage. Here are simulations, so you can give whatever that one. I will going to change, and then I will going to show you demo also. And then here load resistance we are going to giving, and here three switches, positive group, here negative group switches, like the six switches are connected, and one voltmeter connected across about the load, and one ammeter connected in series with the load, like we have connected. Okay, so what are the scope we have connected? One is output voltage. Sorry, first one is input voltage. Then second one is input current. Then third one is output voltage, and the fourth one about the output current. Like we will going to see about the four waveform we're going to see. And next one about theoretically what we are going to learn from that one fully control converters, especially R load. It will be work as a continuous conduction mode and a discontinuous conduction mode. It will be what is a continuous conduction mode period means alpha less than 60 degree when you will going to apply, and it will be work as a continuous conduction mode. When alpha is greater than 60 degree, when it is a move, it will be work as a discontinuous conduction mode. That's it. So you can see about this, and this is told about six sequence. Okay, input based on the input is will going to connect it, and this is a firing angle. So omega t is equal to 30, so it will be start from the 30, and like about 60 degree angle difference between one switch to another switch. Like we will going to first switch we will going to give the 30 degree, and a 60 degree delay. Second switch we will going to give the 90, and a 60 degree delay. Third switch we will going to give the 150. Similarly, fourth switch, fifth switch, and a sixth switch we will going to give, and a sixth switch also 330. 60 degree delay. What is the answer? 330 plus 60, 390. So the one cycle is a 360. So 390 minus 360, 30. So that's why 30 is coming to the roll here. So this is alpha is equal to 0. When alpha is equal to 30 means, okay, add plus 30 in the reference. Add plus 30 in the reference. When alpha is equal to 90 means add plus 90. Add plus 90. Alpha is equal to 90. So add plus 90 in the reference. So let we're going to see about these three things. One is alpha is equal to 0 we're going to perform, and after that alpha is equal to 30 we're going to perform, and after that alpha is equal to 90 we're going to perform, and these two is we're going to see the continuous conduction mode, alpha less than 60-degree continuous conduction mode, and alpha is at 90-degree. When do we apply? We're going to get it as a discontinuous conduction mode. So let we go to see in that one, applying on that one. Okay, firing angle. So first one 30, 90, 150. So like we will going to apply it. Okay. So this is a pulse. Just a double click, and you can see about remaining things as similar to that a single phase fully conduct converters. Amplitude keep it as it is, and the time period 0.02. Y means 1 upon the 50 is equal to 0.02. Okay, then after that pulse width. So pulse width, this is SCR. So 5 is sufficient, or 50 also you can do, nothing is wrong. Okay, so next one you can coming to that one. Here is the alpha. What is the first one? Now I will going to perform about alpha is equal to 0. So what I want to perform, what is the formula? So within the bracket 0 plus 30. Okay. So like about, so formula is I will going to frame. So this is about alpha is equal to 0. Alpha is equal to 0. I am going to perform. Okay. I am going to copy and then paste into the others. Okay. First one is alpha is equal to, okay, and alpha is equal to 0. In that one, switch 1 is a 30. 60-degree, after that 90 will come. Otherwise you can look it on the table. So second one is a 90. Okay, second one I will paste, and here I will go to the 90. Why I will going to write 0 plus 90? 90 only will come. So when I will going to change into the next firing angle, it is easy to, I will going to enter. Okay, 90 over. Then third one is a, what is the third one? 150. Yes, 135. Second, this is the third one. 150. Okay, then fourth one, what is the switch number 4? 2. So where is the fourth switch? This is the fourth switch. 210. Okay, then fifth switch, what is the value? 270. Okay, this is fifth switch. 135. So fifth switch, what is the value I want to enter? 270. I want to enter 270. Then sixth switch is a 330. Okay, that's it. I have entered the given for that. Alpha is equal to 0, omega t is equal to 30. I got given. Just I will going to run. And now alpha is equal to 0. What is alpha is equal to 0? Omega t is equal to 30. So what is the waveform? Let we will going to see. Okay, so this is about the waveform for input voltage. So 100 voltage we are giving for that one, plus or minus. Okay, positive and negative is going, input voltage, input current, and coming back here, this is output voltage and the output current. So what it is coming around 150 voltage and 1.5 amperes, like it is the output of the DC current is coming. Okay, so go back here. What is the my load resistance is giving? 100 ohm. Okay, And now we're going to change about into alpha is equal to 30 degree. So we're going to do the 30 degree. How it will be changed, let me see. So 30 degree we're going to add it here. Simple 0 instead of 30. And here also double click and then you can connect 30. And all the firing angles you can apply the 30 degree. So now I will going to apply it. All the firing angle is 30 degree. So it will be added automatically. So you can see, so like this is a firing angle. Now we are going to apply it. Now we are going to apply it. You know the difference between the three-phase fully contour converter and the single phase, sorry, three-phase fully contour converter and three-phase half contour converters. What is the difference? If it is now I have applied 30 degree, same as it is, only half contour converters means these three control to switches we are going to remove, replace into the diode. So diode we are not giving any pulse, so blank leave it. So that is about the three base off control converters. So we're going to run the circuit. We'll see the waveform. Look it. So this is about the three, it is alpha is equal to 30 degree. So when I will going to apply the alpha is equal to 30 degree, it is a waveform is output voltage waveform is coming and output current is coming. You know, R load condition, output voltage and output current both are the similar type of the waveform. Okay. It will be coming on that one. This is our alpha is equal to 30 degree. Then next we move to the, if you interested, okay, I will show you alpha is equal to 60 degree. Then after that I will going to increase into the 90 degree. So I will going to replace all 30 degree into the 60 degree. So 60 degree will going to replace all of the 60 degree. I have replaced all of the 60 degree. Now I will going to run the program. So running is completed. Then we're going to see the waveform. Once again I am running the program. Running is completed. I will going to click the auto scale and see that one. So you can see it. It is a continuous conduction mode. So 60 and below 60 it will be continuous conduction mode. So that's it. Let me going to go for that above more than 60 degree. We're going to apply it either the 70 degree or 80 degree. So we will going to apply it. So what is the waveform? So let it will going to take about round value 90 degree. So how about it is performing? Let we're going to see it. So after once I will going to create the reference, I am not change the reference. So keep it a reference as it is. Only I will going to apply for that alpha value. So alpha value directly I will going to apply. So it will be calculate automatically. So I will going to use the proper bracket. So I have applied, then run the program, and here is one thing. Uh, Look at what you want to apply here. We'll want to. Sixth one should be 60 degree. Okay. Fifth one is a 360 degree. It will become. Fifth one is a this is 135. Okay. Fifth one, what is the value? So 270 plus 90. So 360 degree. Okay, it is coming correctly. Another one, when you will going to see it, sixth one should be 60 degree. Sixth one should be 60 degree. Okay. So your wave where is sixth one? See, look it more than here 360. I mean more than 360 degree. I'm going to apply. So that's not a correct one. So I will going to delete it, and I will going to apply directly. What is the value? 60 degree I need to apply. 60 degree, correct? So this is a value I want to apply. So that's it, and click it OK, then run the program, then double click the scope. Once again run the program for your reference. Okay, running is completed. So alpha is greater than 60 degree means it is called a discontinuous conduction mode. So that should be very clearly note it on your point. I will repeat about theoretical point. Alpha is less than equal to 60 degree means it will be continuous conduction mode. Alpha is greater than 60 degree means discontinuous conduction mode, especially three-phase fully control converters. And half control converter also, it will be similar, it will be work. And this is a part you can understand. But when you will want to look at about single phase fully control converters, single phase fully control converter also, it will be work. Continuous conduction mode, discontinuous conduction mode, it will be work, but their case is totally different. So when you will going to get the continuous conduction mode, when you will going to get the discontinuous conduction mode means their case is what it will be, say R and L is dependent. So R is greater than L means the waveform is a discontinuous conduction mode for single phase fully control converters. Single phase fully control converters, R is present, L is present. If you want to discontinuous conduction mode for the voltage and current, both also output voltage and output current, both also discontinuous. If you want, alpha is not equal to the beta, so that is called discontinuous. So what is the case? R is greater than L. What is R is greater than L? R value is 100 ohm, L is a 50 millihenry. In that case, is discontinuous conduction mode. Just I will going to recap about the concept. Another one is a continuous conduction mode. In that a single phase fully control converter, continuous conduction mode. What is a continuous conduction mode? L is greater than R. L is greater than R. In that case, you will going to get the continuous conduction mode output you can get. What it will be, say continuous conduction mode means beta it is equal to alpha. Beta it is equal to the alpha. So that is a continuous conduction mode. What is L value? For example, 500 millihenry. R value 10. So 10 ohm. So in that cases, L is greater than R. So in that cases only you will going to get about that continuous conduction mode. So see, once again for your understanding, I am explain single phase fully control converter, continuous, discontinuous. You can achieve with RL load and R value and L value. Based on that one, you will going to achieve. It is not related to the alpha. It is not related to the alpha. But three-phase fully control converters, discontinuous, continuous, you will going to achieve related to the alpha. That is a concept. That is a concept only. Okay, coming to here, three-phase fully control converters, alpha is a greater than 60 degree. What is the firing angle we are applied? 90 degree. We are applied the firing angle is 90 degree. 90 degree means alpha is greater than 60 degree. So it is a, what is a waveform? Discontinuous waveform. That's it. You can look it on that one. What is the waveform is achieved? Discontinuous waveform. So perfectly it is coming. That's it. So here R load is over. So next one you can perform about the RL load. Okay. Let me try with the RL load, and after that we go for that semi-controlled converter, or another name it is called, what is another name? It is called off control converters. Okay. RL load. So L value So L value we will need to apply. I will go to trial and error. So 50 millihenry, 50 e power minus 3 I am giving. Okay, so keep as it is the 90 degree. Run the program. Look it, this is about your RL load waveform is coming. RL load, what it is showing, what it is try to say. So two quadrant, positive quadrant has, I mean quadrant number 1 and quadrant number 4, like it will be working on that one, it is showcasing. Okay, so we will do the research about the RL load on the some other video. First we will going to do only RL load. So RL load part is we are going to complete it here. Okay, three phase fully control converters, what is the part is completed? R load part is completed. I don't want to go for that R load. So only R load. Next one is a semi control converter. I will going to teach you. So later we'll going to go with the semi control converters. So alpha is greater than 60 degree. So that means alpha is equal to 90 degree we have applied. So we are getting for that discontinuous conduction output. Okay. Now what the same alpha, same alpha. Okay. Suppose you can see it, switch number 2, switch number 4, 6, switch number 6. So these are the okay uncontrolled switch. So okay, and what about that one firing angle? Same. So you can apply the same firing angle. That firing angle we are not touched. Okay, as similar the concept. Okay, so I don't want delete, delete, delete. Okay, only you need to connect it about diode. Let me slow. Use control R for rotating and take it, connect it to here. So that's it. This is called the circuit is called now we are getting three phase half control converter. That's it. So as usual, you will want to increase alpha is equal to 0, alpha is equal to 30, alpha is equal to 90. You can increase. So here I have increased. What I have increased 90. I have increased. Okay. So alpha is equal to 90 in the reference I have added. So along with the reference I have added. Okay. So you can see it. This one to this one differentiation is a you can check in the reference. The differentiation is a 120 degree. From here to here is a 120 degree. Okay, just run it. Let me see what about their waveform. So this is a waveform. So what you're trying to understand, similar waveform, alpha is greater than 60 degree discontinuous waveform we are going to getting as similar waveform. What is a similar waveform? Fully control converters. What is a discontinuous wave condition? Same discontinuous conduction. Alpha greater than 60 degree. Same conditions we're going to get it. Okay, that one is output voltage is more than 150 voltage. Here you can see it, the output voltage is 150, and that current also more than 1.5 it is produced, but here is the current is a 1.5. So here also same, alpha less than 60, alpha is greater than 60. Okay, that less than 60 about continuous, greater than 60 discontinuous as similar. Okay. Okay, now for example I will going to change into the 60 degree. 60, 60. 60. That's it. Run it. You can double click on this code. Okay, see there continuous conduction mode output is coming. Continuous conduction mode output is coming. So what is that one? Alpha is equal to 60 degree I have applied. 60 degree I am applied. Then next one, alpha is equal to 30 degree. Actually alpha is equal to 30 degree. Theoretically waveform is totally different waveform. That is the 1 3, like it is a waveform will come. So 1 1 3 model you can refer in the book or your PPT. The year 3-phase half contour converter, especially alpha is equal to 30 degree, their waveform is a 1 3. You can see the table, then you can understand what is a 1 3. So this is 30 degree. So here you can see it. Okay, 30 and after 90 degree. 1 3. That is a differentiation. 1 3 1 3 1 3. Like it is a theoretically your waveform is a, you will going to get it. So let me see here simulations 30 degree. 30 degree. 30 degree. Then run the program. Okay. So this is a really very good about waveform is getting. So 30 degree, 90 degree, 30 degree, 90 degree. So this is a waveform for the especially alpha is equal to 30 degree. So all of you take a note, the very clear, accurate waveform we are going to getting. So this is alpha is equal to 30 degree. Where what is that? A 3-phase half control converter. 3-phase half control converter. Alpha is equal to 30. Only you need to memorize the waveform on your mind. What I'm saying, 3-phase fully contour converter, except alpha is equal to 30, remaining waveform has similar ditto. 3-phase fully contour converter R load and 3-phase half contour converter R load. Remaining all the waveform are ditto. Ditto means same, similar. Except alpha is equal to 30. This alpha is equal to 30, especially 3-phase half contour converters, this is a waveform. 1 3 1 3. What is that one? 30 degree, 90 degree, 30 degree, 90 degree. What I'm saying, you can see it here. So where is that one? Conduction period. Here is a conduction period. This is a waveform will be reflected. This is a waveform is reflected. And this is a waveform is reflected. You need to take a graph sheet. In the graph sheet, input voltage after that line to line waveform you can draw. And the line to line waveform after draw you can substitute it. And this is a waveform you can achieve it. That's it. So very clear we are going to getting the waveform. What is the output voltage? So less than 150 voltage range it is a okay 150 range it is getting 1.5. Okay, then last one. Alpha is equal to 0. So hope you are going to understand what is the difference between the firing angle I am applying here. Okay, variation of the firing angle. Okay. So alpha is equal to 0. Okay. Run the program. Only first references are applied properly in bracket, and after that, wow, it is a very clear waveform is showcasing. Yes. So very clear waveform is showcasing on that one. Alpha is equal to 0. So this is as similar to your what is the waveform 3-phase fully contour converters. This waveform is achieving. Okay, that's it. So this is about the difference between the 3-phase half contour converters and the 3-phase fully contour converters. Okay, so here is a controlled switch is replaced into the uncontrolled switch, That's it. Okay, one second I will going to show you. So what is this? Three. This is called the VI measurement. Directly you can take it, and you can take about the voltage measurement phase to ground. Okay, like you can take it. Okay, and the current measurement. Yes. Okay, you can take it. And here this is a input. What is this one? Three-phase sources. So three-phase sources you can use it, and here you can give whatever. Suppose you can increase 440 voltage, also you can increase. That is doesn't matter. Okay. Here configurations YG we are going to giving frequencies would be 50. So that is important. Okay. And the load resistance 100 ohm. I am going to apply it. So just you can insert it 440 voltage. See, this is our input waveform. Okay, 400. So like it is going on. So this is about alpha is equal to 0 waveform. It's okay. See there. Here you can see it should be start from that one. This is a way you want to take the paragraph. See, look it. Uh, when I will going to press again on auto scale, you can see it will be start to increase and then like it is a going. So this is about the same similar manner you want to do. Likely you can one time, two time, just click it. Okay, once again. Okay, so you can click it. Then you can take it the waveform screenshot. That's it. So this is the way you want to perform. So next video we're going to see about that RL load, and you can go with the try with that RL load yourself also, no problem. That's it. Thank you.